Apollo here.
This is Houston. Say again, please.
Houston, we've had a problem. We've had a main B plus undervolt.
Roger, main B undervolt. Okay, stand by, 13. We're looking at it.
On April 11th, 1970, NASA launched Apollo 13, the 13th mission of the Apollo program and the third mission set to land on the moon. The excitement was palpable as NASA had big dreams of landing on new lunar sites with precision, conducting revolutionary geological research, and collecting invaluable lunar samples. The mission held the promise of making history. But Apollo 13 would not become famous for its triumphs. It would become etched in history for a story of survival, ingenuity, and human determination in the face of a disaster that nearly ended in tragedy. Just days into the mission, an oxygen tank exploded in the service module, crippling the spacecraft's life support and electrical systems. What was meant to be a groundbreaking mission to the moon suddenly turned into a fight for life itself, forcing the crew to abandon their moon landing plans and improvise in the desperate hope of getting back home. Before we dive into the nail-biting sequence of events that followed, let's meet the brave crew members of Apollo 13, men who transformed a disaster into a testament to human resilience and ingenuity. Their story is one of extraordinary courage, where every second counted and every decision made the difference between life and death. Apollo 13 was led by Commander Jim Lovell, a seasoned astronaut who at 42 had already made history by becoming the first person to fly to the moon twice. Alongside him was Jack Swigert Jr., the command module pilot, an Air Force veteran who had been part of the Apollo 7 support crew, eager to prove himself in space. The lunar module pilot, Fred Hayes Jr., was no stranger to spaceflight, having served as backup for both Apollo 8 and 11. These three men, each with their own dreams and experiences, were on the brink of what they thought would be a routine mission, until everything changed in an instant. Like all Apollo missions, Apollo 13 relied on a powerful Saturn V rocket to carry the astronauts to the moon. This rocket was nearly identical to those used in Apollo 8 and 12, though it produced slightly less thrust than Apollo 12's. For the first time, extra propellant was added to the rocket to test for future missions, making it the heaviest rocket ever flown by NASA. The spacecraft was made up of the command module and service module, named Odyssey, and the lunar module, called Aquarius. It also had a launch escape system designed to eject the command module to safety if something went wrong during liftoff. Liftoff took place from Kennedy Space Center in Florida on April 11, 1970, after a delay from the original March 12th launch date. The postponement allowed more time for planning and set the pace for 2 Apollo missions per year, following the cancellation of Apollo 20. For Apollo 13, the crew underwent over 1,000 hours of mission-specific training, including more than 100 hours in the command module simulator. Lovell and Hayes also spent hundreds of hours in the lunar module simulator in Houston, practicing emergency scenarios with flight controllers. Little did they know, these exercises would become crucial. While the previous Apollo crews had limited geology training, Apollo 13's astronauts took it a step further. Influenced by NASA astronaut Harrison Schmidt's advocacy for more geological expertise, Lovell and Hayes met with his former professor, Lee Silver. The result? A field trip that not only sparked their enthusiasm for geology, but also led to Silver becoming their mentor, shaping the geological focus of their mission. Apollo 13 was set to land near the Fromauer crater, a region thought to contain material ejected by the impact that formed the Imbrium Basin, a vast plain created by a collision with a protoplanet. Studying this area was seen as crucial not only for understanding the Moon's history, but also offering insights into the early Earth. Among the planned experiments, the crew would have a nuclear-powered seismometer to replace the solar-powered one left by Apollo 11, which failed during the lunar night. Hayes was tasked with drilling 2 3-meter holes to extract core samples. Additionally, they carried a lunar atmosphere detector and a dust detector to measure the accumulation of lunar debris. In addition to geological work, the crew planned to take photographs of the Moon, the Lagrangian points, and of the Earth-Moon system, a unique feature known as the counterflow, a particularly bright spot in the night sky. If you'd like to learn more about the Lagrangian points, let me know in the comments below. On April 11th, at 2:13 p.m., Apollo 13 lifted off. However, a problem occurred when the center engine of the second stage shut down about 2 minutes early due to pogo oscillations. These oscillations are self-induced vibrations caused by combustion instability in the propellant. While protocols existed to manage these anomalies, the effects were significantly amplified during Apollo 13. To compensate, the third stage engines burned longer and the spacecraft arrived at its 190 km parking orbit. After that, the crew performed a translunar injection, setting their course for the moon. Swigert then executed several maneuvers to dock the command module Odyssey with the lunar module Aquarius. Once the docking was completed, the crew began their journey toward Fremaro. 30 hours after liftoff, they performed a burn to adjust their trajectory from a free return path, which only allowed for a lunar landing near the equator, to a hybrid trajectory, enabling access to higher altitude sites like Fremaro. If they hadn't done this, they would have missed Earth on their return. Amid the mission, something unexpected happened. Swigert realized he had forgotten to file his federal income tax return. He laughed with the mission controllers, joking if he could get an extension, which they granted since he was out of the country at the time.
Uh-oh. Have you guys completed your income tax?
How do I apply for the extension?
Yeah, Joe, I gotta. Hey, that ain't too funny. Things kind of happen real fast down there, and I do need an extension. I didn't get mine filed. I'm really serious.
58 hours into the mission, the crew entered the lunar module to test its systems. They also started a television broadcast where Lovell showed the interiors of both the Odyssey and Aquarius. However, no network was carrying the broadcast, so Lovell's wife, Marilyn, had to go to mission control to watch her husband. At almost 56 hours into the mission, Apollo 13 was about 330,000 kilometers from Earth. Hayes was shutting down the lunar module and Swigert was preparing to change the spacecraft's attitude to capture photos of Comet Bennett. Meanwhile, a malfunction was detected in one of the oxygen tank pressure sensors, so Swigert activated the stirring fans in the tank to improve the accuracy of the readings, a routine task done once daily. But just minutes after the telecast, a loud bang echoed through the spacecraft, followed by fluctuations in power and firing of the attitude control thrusters. Communications were briefly lost, but as soon as they were restored, Swigert famously reported,
Okay, Houston, we've had a problem here.
At first, Lovell thought the sound was a prank by Hayes, who sometimes activated the cabin repressurization valve, causing a similar bang. But Hayes had no idea why it happened. They briefly considered the possibility of a meteoroid strike, but there were no signs of leaks. Then they noticed that the main bus B was undervolt, indicating insufficient voltage from the fuel cells. Hayes quickly discovered that 2 of the 3 fuel cells were dead. Within moments, readings indicated that oxygen tank 2 was empty, and tank 1 pressure was slowly falling. The computer had reset, and the antenna was not working. Flight controllers initially suspected an instrumentation issue, but Lovell soon saw gas of some sort venting into space, confirming that the situation was far worse than anticipated. With the command module's oxygen running low, the crew had to rely on its batteries and the surge tank oxygen. However, these resources would only last a short time. Flight controllers ordered the isolation of the surge tank to preserve its oxygen, but the rest of the spacecraft's oxygen supply would be depleted within 2 hours. In the aftermath of the explosion, the spacecraft was surrounded by bits of debris, and the mission's objective had drastically shifted to bring the astronauts back to Earth, alive. The flight controllers made a critical decision. They would power up the lunar module and use it as a lifeboat. This was a scenario they had anticipated, though not in these exact circumstances. Procedures for using the lunar module in such an emergency had been developed since Apollo 10, but now it was being put on the ultimate test. A crucial decision loomed. Should they perform a direct abort and use the service module's engines to return home immediately? However, the risk was too high. The engines might have been damaged during the accident, and there wasn't enough fuel to execute a safe return. So the mission took an unexpected turn. The spacecraft would swing around the moon and then head back to Earth. This longer, more complex route would require the lunar module's descent propulsion system, but there was a catch. The software to control the system from the lunar module had never been developed. Flight controllers scrambled to adapt, needing new software to navigate the spacecraft. As a sense of urgency mounted, Lovell took matters into his own hands. With the command module's guidance system shutting down, he carefully copied the spacecraft's orientation data and performed the delicate calculations to transfer it to the lunar module system. It was a painstaking task, but at 61 hours into the mission, the descent propulsion system fired and putting Apollo 13 back on a free return trajectory, a longer, safer route home. This maneuver would ensure the astronauts would return to Earth in about 4 days, with a splashdown in the Indian Ocean. But there was a problem. Recovery forces were minimal there. In a race against time, flight controllers worked tirelessly to find a way to shorten the journey. After careful consideration, they decided on a strategy that would shave 12 hours off the return time by using the lunar module's descent propulsion system to adjust the spacecraft's trajectory. This would change the splashdown location to the Pacific Ocean, where recovery operations were better equipped. As Apollo 13 approached the closest point to the Moon, he set a new record, the furthest distance ever traveled from Earth by crewed spacecraft, 400,171 kilometers. Yet this achievement was bittersweet, as it symbolized not exploration, but the crew's struggle for survival. The accuracy of the burns that would bring them home was vital. Lovell's hand calculations provided guidance, but the presence of debris scattered from the accident made the usual star-based navigation difficult. So the crew relied on the one celestial body that could be obscured by the chaos, the Sun. Once the burn was complete, the crew powered down most of the lunar module's systems to conserve precious resources. The astronauts faced a series of harrowing challenges as they continued their struggle for survival. While the lunar module had enough oxygen to sustain the crew, the real problem lay in the removal of carbon dioxide. The CO2 canisters in the lunar module were designed for short-term use and were insufficient for the extended journey home. But NASA engineers, working under immense pressure, came up with a clever solution. They suggested that the crew could improvise using plastic covers torn from manuals and duct tape to create a makeshift adapter, allowing the canisters from the command module to be used in the lunar module. It was a desperate measure, but it was their only option. The next major concern was water. The command module's fuel cells produced water as a byproduct, but the lunar module used a different power source that didn't generate water. Power and water became critical commodities, and the crew was forced to reduce power consumption to the bare minimum. Swigert was able to collect small amounts of water from the command module's tap, but despite rationing their personal consumption, they would have run out of water for cooling just 5 hours before re-entry. In a situation where every drop counted, this was a frightening prospect. But in the end, the decision was made that the situation was acceptable. They could survive on a mere 0.2 liters of water per person per day. However, the toll on the crew's bodies was significant. With the extreme conditions and the water shortage, the astronauts lost a total of 14 kilograms among them. Hayes developed a urinary tract infection, a painful reminder of their physical suffering. Inside the lunar module, the temperature plummeted to as low as 3 degrees Celsius. The crew huddled together for warmth, wearing their EVA boots and extra coveralls to keep them from freezing. But even that wasn't enough to stave off the cold. Swigert, who had gotten his feet wet while collecting water and wasn't supposed to be performing an EVA, struggled more than the others. He had no boots and was shivering uncontrollably. Meanwhile, the flight controllers back at Mission Control worked tirelessly to find a way to bring Apollo 13 home. Many engineers collaborated to develop a procedure that would allow the command module to be restarted from shutdown. This was no small feat. Every step had to be calculated with precision. With cold conditions and fatigue wearing on the crew, Mission Control powered up the lunar module after 133 hours, warming the cabin and restarting its computer. This crucial step allowed Lovell to calibrate the lunar module's navigation system, which would then be used to align the command module's computer. This would streamline the re-entry process and ensure the accuracy needed to make a successful splashdown. As Apollo 13 made its perilous journey back to Earth, the crew faced yet another challenge. The spacecraft required a course correction. With the lunar module's guidance system shut down, the astronauts were told to rely on a technique never before used in such a critical moment. Using the line between night and day on Earth, known as the Terminator, as a navigation guide. It was a technique that hadn't been considered for such a situation, but it worked. Using the descent propulsion system, the crew was able to bring Apollo 13 back within the safe limits of its trajectory. But the danger was far from over. Another burn was needed, this time using the lunar module's reaction control system to further adjust their course. With that done, they jettisoned the surface module, a moment of grim revelation. As the module separated, the crew saw the extent of the damage, significant destruction that had almost cost them everything. They took photographs of the wreckage, the visible scars left by the explosion. Next, the crew moved back into the command module and reactivated its life support systems, a procedure that had been hastily devised in preparation for this very moment. It wasn't something that they had been trained to do, and it was never intended to be used in flight, but the sheer willpower of the astronauts and the ingenuity of the flight controllers had brought them this far. The final problem to be solved was how to safely separate the lunar module from the command module just before re-entry. Grumman, the manufacturer of the lunar module, had assigned a team from the University of Toronto to find a solution, and their method worked perfectly. With the lunar module separated, it enters Earth's atmosphere and was destroyed. But as the command module began its re-entry, another danger loomed. Usually, during re-entry, the command module would lose communications for about 4 minutes due to the ionized air surrounding it. However, Apollo 13's shallow re-entry path extended the period to 6 minutes, causing fear and uncertainty in mission control. There were real concerns that the heat shield had failed and that the crew's survival was hanging by a thread. Then, after what felt like an eternity, the spacecraft broke through the atmosphere and splashed down safely in the South Pacific Ocean, near American Samoa. The crew had made it. They were alive. Though the crew emerged from the spacecraft in relatively good condition, Hayes' urinary tract infection had worsened due to the conditions in space. After being picked up by recovery forces and transported to American Samoa, they were flown to Hawaii. In a moment of profound recognition, President Richard Nixon awarded them the Presidential Medal of Freedom for their bravery and perseverance. The mission that was meant to land on the moon had instead become a fight for survival, a fight they had won against all odds. Finally, after everything they had endured, the crew made their way back to Houston, where they were greeted as heroes. Their courage, resourcefulness, and unyielding spirit would forever define the legacy of Apollo 13. The Apollo 13 incident reignited global interest in space exploration, with millions watching live coverage as nations, including the Soviet Union, offered help. President Nixon cancelled appointments, contacted the astronauts' families, and visited NASA's Goddard Space Flight Center. The mission captured more attention than any since Apollo 11, with prayers from Pope Paul VI and millions worldwide. On April 14th, the US Senate encouraged a national moment of prayer. When the astronauts splashed down safely in the Pacific, an estimated 40 million Americans and millions more globally watched, united in relief. For Apollo 14 and beyond, the oxygen tank was redesigned with upgraded thermostats and the removal of steering fans, requiring a third tank to ensure redundancy. This third tank, placed opposite the others in Bay 1, had an isolation valve to fill only the command module if needed. Stainless steel replaced aluminum in the quantity probe, and all Bay 4 wiring was shielded in stainless steel. Fuel cell valves were redesigned to isolate wiring from oxygen, and monitoring systems were improved for faster anomaly detection. Emergency water and battery supplies were added, and the lunar module was modified for easier power transfer to the command module. On February 5, 1971, Apollo 14 successfully landed on the moon, exploring the Fra Mauro crater, originally targeted by Apollo 13's crew. After the accident, none of the Apollo 13 astronauts flew to space again. Lovell retired from NASA and the Navy, transitioning to the private sector. Swigert, who had been slated for the 1975 Apollo-Soyuz test project, was removed from the mission and left NASA in 1973 to enter politics. He was elected to the House of Representatives in 1982, but tragically passed away from cancer before he could be sworn in. Hayes was set to command Apollo 19, but the mission was cancelled, and he retired from NASA in 1979. The Apollo 13 mission has become one of the most famous in history. Books have been written, movies made, and it has become a defining moment that everyone knows. The phrase, "Houston, we've had a problem here," spoken by Swigert, became iconic, though often misquoted. In conclusion, Apollo 13 stands as one of the most challenging space missions humanity has ever faced. However, its ultimate success is a testament to the skills and determination of the men and women who worked tirelessly to save the crew. It highlights not only the value of human life, but also the resilience of human spirit, proving that we are capable of overcoming even the greatest challenges. We should take immense pride in this achievement.